Hey everyone! When it comes to developing multiplayer games, hosting and scaling your servers dynamically is always a major challenge. AWS GameLift is one of the most mature solutions in the industry, but integrating it into Godot from scratch usually means spending weeks wrapping complex C++ SDKs. Not anymore. Today we are excited to introduce the GameLift Server SDK for Godot. This add-on lets you integrate and connect your dedicated servers with AWS GameLift inside Godot with absolute ease. It handles the essential bridge communication, allowing your Godot server to receive game session requests, process updates, and handle graceful termination directly from the GameLift service. Even better, it fully supports GameLift anywhere. This means you can use our add-on to test and debug your dedicated servers locally, right on your development machine, without deploying to the cloud. Plus, if you want to run a hybrid or on-premise setup, GameLift Anywhere allows you to use your own physical machines to host production-dedicated servers under AWS management. When you are ready to deploy, the SDK exports perfectly across Windows, Mac OS, and Linux for your server builds. And our Linux support is incredibly robust. It includes native support for SteamOS, which is massive for targeting devices like the Steam Deck, as well as Linux ARM64. This allows you to deploy on ARM-based AWS Graviton instances, which deliver excellent performance while significantly slashing your managed EC2 hosting bills. Finally, to make your life easier, we've designed this SDK with a unified codebase in mind. If you are exporting client builds to mobile platforms like iOS and Android, the SDK automatically provides clean, empty stub functions. This means you can keep your server management code intact without triggering annoying compilation or runtime errors on mobile. True cross-platform development workflow right out of the box. Now, if you've ever tried running a Godot dedicated server in production, you've likely run into a frustrating bottleneck. In modern multiplayer architecture, running multiple server instances on a single machine is essential. For session-based games like match-based shooters or MOBAs, you need to run dozens of separate game sessions simultaneously on one EC2 instance to keep hosting costs down. Even for MMOs, you often need to run multiple processes to handle different game zones, or to keep backup processes on standby in case a main process crashes. However, by default, Godot's log system only supports writing to a single, static log file. This means if you launch multiple server instances on the same machine, the newer process will immediately overwrite the log file of the older one. To bypass this, developers often resort to running just one Godot instance per machine, which heavily wastes hardware resources and completely defeats the lightweight, high-performance advantages of Godot. Our add-on solves this problem elegantly. We have built a robust, custom log ownership and rotation system. Each running Godot dedicated server instance uniquely claims and locks its own dedicated log file. When an instance shuts down, it automatically releases its lock on that log. When a new instance spins up, it detects the inactive log, automatically backs up and rotates the old file, and safely takes over the log slot. Now, no matter how many Godot instances you run on a single machine, your logs are perfectly organized, debugging is a breeze, and your hardware utilization is fully optimized. Once your servers are up and running, how does your client actually request a game session and connect to the fleet? You technically have two pathways here, but one is going to save you weeks of back-end headaches. Option 1 is the DIY route. You can manually route requests through AWS API Gateway, write custom AWS Lambda functions to handle the GameLift API calls, set up complex IAM permissions, and manage your own API infrastructure. While this is a valid path if you already have a dedicated web backend team, it requires a lot of extra cloud architecture, maintenance, and debugging outside of Godot. Option 2 is the ultimate shortcut, our premium GameLift for Godot add-on. Instead of wasting days setting up and paying for API gateways and Lambda functions, this add-on lets your Godot client talk to GameLift directly and securely, right out of the box. It completely bypasses the need to write backend API glue code. Best of all, we've built this client add-on to run absolutely everywhere. It features full native support for Windows, Mac OS, iOS, Android, and Linux. And yes, That Linux support includes SteamOS for seamless Steam Deck integration, as well as Linux ARM64 architectures. If you want to go from a blank project to a fully connected, cross-platform multiplayer game in under 10 minutes, this add-on is a no-brainer investment that pays for itself on day one. The client-side add-on exposes the full power of the AWS GameLift SDK, but instead of forcing a rigid C++-style API on you, we designed it from the ground up for Godot. Every single API function is fully asynchronous. By utilizing GDScript's native await keyword, you can cleanly handle network requests without ever falling into callback hell. All AWS data structures are mapped directly to GDScript resources and objects, giving you great autocomplete support. The add-on integrates seamlessly into Godot's built-in help system. Simply press F1 in the editor to search for any class or method. It behaves exactly like Godot's built-in APIs. Now, let's look at how easy this is to set up in action. We'll start with local testing. To get you up and running instantly, we provide a custom AWS CloudFormation template specifically designed for local development. Setting it up is incredibly simple. In the AWS console, upload our AWS template_GameLift_localtest.yaml to CloudFormation, give it a name, and deploy. Once the stack is ready, open up the AWS Cloud Shell. We need to run two quick AWS CLI commands to link our local machine to our new Anywhere fleet. First, call register-compute to register your local machine as a compute resource. Next, call get-compute-off-token to generate a temporary authorization token. Over in Godot, we use these returned values, along with the specific AWS region where we deployed our CloudFormation stack, to construct our Amazon GameLift server parameters object. Pass those parameters into the GameLift server SDK to initialize the SDK and call process_ready. With our code ready to go, we export our dedicated server build from the Godot project. Now, we can launch our exported binary on our local machine, and it instantly registers itself as active, healthy, and listening to your Anywhere fleet. Finally, in our game client, we use the GameLift for Godot client add-on to request a game session and a player session. Just note that to make these client requests, you'll need to construct a GameLift object using valid AWS credentials. For a clean, secure way to handle those user credentials, be sure to check out my next video covering our Cognito for Godot add-on. Look at that! The client add-on talks directly to GameLift, claims the local session, and connects our game client to our local dedicated server seamlessly. No cloud hosting costs, 100% offline-friendly testing. When you're ready to transition to the live cloud, we have a second CloudFormation template that automates your entire production deployment. This template automatically provisions your secure managed EC2 fleet using a game build you've uploaded to your own Amazon S3 bucket. Here is the live workflow. First, create an S3 bucket and upload your zipped Godot dedicated server binary straight to it. Next, deploy our AWS template_GameLift.yaml template in AWS, providing your S3 bucket name and build file details as parameters. AWS automatically pulls the build from your bucket, deploys it to your fleet, and activates your instances. Once it's active, we launch our game client, trigger our GameLift client add-on code, and boom! We are connected to a high-performance managed EC2 instance running our Godot server in the cloud. It's that simple. Best of all, thanks to our custom log system, once a game session terminates, each server instance's log is captured separately. You can go straight to the AWS GameLift console under Game Sessions and download the exact log file for that specific terminated session with a single click. Whether you're building a cozy co-op game or a massive multiplayer battle royale, this GameLift Server SDK for Godot and its companion client add-on handle all of the heavy cloud infrastructure lifting so you can focus on making your game fun. You can find the links to both add-ons, the CloudFormation templates, and our official Discord server down in the video description below. If you found this video helpful, please hit that like button, subscribe for more Godot tutorials, and share this with your fellow developers. Let us know what you think in the comments below, or jump into our Discord server to tell us what you need. Thanks for watching, and happy game developing.